In this video, we're going to talk about simplifying complex rational expressions, sometimes called complex fractions. You're going to recognize a complex fraction when you see fractions within a fraction. Our first example, you're going to notice that we have x over 3 plus x over 6, that whole thing divided by x over 2 plus x over 3. To simplify a complex rational expression, I'm going to start by finding a common denominator, which is going to be my LCD. When I look at my denominators, I see a 3, a 6, a 2, and a 3. I'm going to find the least common multiple for those denominators. The least common multiple for a 2, a 3, and a 6 is going to be 6. Once I find the LCD, I'm going to multiply each of these fractions by that common denominator. If I multiply each of these fractions by 6, we're going to notice that our denominators are all going to go away. In my first fraction, if I take x over 3 and I multiply it by 6, the 3 is going to cancel, the 6 becomes a 2, I multiply what's left, and I now have 2x. Second fraction, x over 6 multiplied by 6. This 6 is going to cancel with that 6, I'm left with an x. In my denominator, I'm going to take this 6 and multiply it by x over 2. This 2 is going to cancel, this 6 becomes a 3, I multiply the 3 times the x, and I get x. Last fraction, the 3 is going to cancel, the 6 becomes a 2, 2 times x is going to be 2x. By finding my common denominator and multiplying it by it, I've now eliminated those fractions of the fractions and made things a lot easier. I'm now going to combine my terms in my numerator, 2x plus x, which is going to be 3x. And then in the bottom, it's 3x plus 2x, which is going to be 5x. Once I've combined like terms in both the numerator and denominator, I can reduce the fraction. I'm going to notice that the x that's in the top and the x that's in the bottom I can cancel out, leaving me an answer just 0 at the bottom. So by finding that common denominator, clearing those fractions, we can make it a whole lot easier to work with. Second example, same thing. I'm going to take a look at my denominators and I'm going to find my least common denominator, which is just my least common multiple for all of my denominators. In this case, the LCD is going to be 3x. I need to get rid of a 3, I need to get rid of an x, so I'm going to use 3x as my common denominator. I'm going to multiply every one of these fractions by 3x. And I'm going to cancel my denominators as I go. Now, the first one, 1 over 3 times 3x, the 3 is going to cancel with the 3, x times 1 is going to give me an x. Second fraction, 1 over 3x being multiplied by 3x, the 3x cancels with 3x, and I'm left with a plus 1. Bottom left fraction, the x that I have in the bottom here is going to cancel with the x that's there, 3 times 1 is going to be 3. And then at the bottom right, the 3 is going to cancel with the 3, 1 times x is going to be x. Now at this point, I would look to combine my terms if I had some, I would look to reduce it if I could, but my final answer is going to be the top staying as x plus 1, and then the bottom is going to be x plus 3. You don't have to rewrite the 3 plus x as x plus 3. I typically write my variables. Next example, same idea. If I were to look for a common denominator here, I have a denominator of a and a denominator of a squared. If I have the same variable raised to a different exponent, I'm going to use the larger of the exponent. So I'm going to use a squared as my common denominator. I'm going to take the fraction that's in the top and the fraction that's in the bottom, and I'm going to multiply both of them by a squared. That means that this a is going to reduce with that a squared. I multiply what's left, and it's a times a minus 1. In the denominator, the a squared cancels with the a squared, and I'm left with a squared minus 1. The only thing I'm going to do at this point is look to reduce this rational expression. We should know at this point, to reduce the rational expression, we're going to factor and then we're going to cancel. My numerator is already factored. Greatest common factor of a and then a minus 1. But my denominator is the difference of perfect squares, so that becomes a plus 1 times a minus 1. Once I have factored both the numerator and denominator, the a minus 1 cancels with the a minus 1. I'm left with an a in the top and then a plus 1 in the bottom. Please remember, do not cancel the a in the top with the a in the bottom. That a in the bottom is part of the binomial. You can only cancel the entire thing or nothing at all. Next example, same idea. We're going to find a common denominator. Common denominator is going to be m squared n squared. Again, if we have the same variable raised to different exponents, it's the larger exponent is the one we're going to use. So I'm going to multiply each of these fractions by that common denominator, which is m squared n squared, m squared n squared, m squared n squared, and m squared n squared. Now, as I multiply, things are going to reduce, things are going to cancel. This m is going to get canceled, this m squared is going to become an m. So it's now mn squared times 1, which is mn squared. Over here, the n is going to reduce with the n squared, and I'm going to be left with plus m squared n. In my denominator, this m squared is going to cancel with this m squared, leaving me an n squared times 1, which is n squared. Over here, n squared cancels with n squared, so I'm left with minus m squared. Once we've eliminated all of those little fractions within fractions, now we need to reduce our rational expression. I'm going to factor the top, factor the bottom, and look to cancel. In the top, I see a binomial. I'm going to start by looking for a greatest common factor. Looks to me like my greatest common factor is going to be mn. Inside of my parentheses, I'm going to have an n plus m. In my denominator, I see that I have n squared minus m squared. Again, it's the difference of perfect squares. It's a perfect square minus a perfect square, so I'm going to factor it appropriately. I'm going to have n plus m and n minus m. Once I've done my factoring, I'm going to look to cancel, look to reduce. N plus m cancels with n plus m. In my numerator, I have mn, and in my denominator, I have n minus m. And that would be my final answer. Again, all we're doing is finding our common denominator, multiplying everything by that common denominator to clear our fractions. Now, our next couple of examples are pretty straightforward, and I would suggest that we try them on our own. We'll go through them in class tomorrow.